Hello everyone, I am Aseem Srivastava, currently a PhD student at IIIT Delhi, India, and today I am going to present my work, which is Knowledge Planning in Large Language Models for Domain-Aligned Counseling Summarization. This work is in collaboration with my co-authors, Smriti Joshi from WISA and my advisors, Dr. Tanmoy Chakraborty from IIT Delhi and Dr. Shad Akhtar from IIIT Delhi. Now, before starting to discuss on the work, let's first understand what counseling conversations are and what counseling notes are. A counseling conversation is a typical setup where therapist and a patient interact with each other in order to receive or provide support. Okay. Now, during this process, the therapist is required mandatorily to, to maintain a record of all the key points in a summarized way. Now, this summary is also called counseling note. The problem is, while maintaining this counseling notes, the therapist has to take care of multiple jobs. Also, to understand the patient's dynamic, to understand the patient's emotions, to be empathetic at the same time, and then maintaining the counseling notes also. We understand that AI cannot take care of everything in the nature, but there is some way AI can help in here, at least in the space of providing them with the effective counseling summaries. Before even getting started into the space, let's check what the real mental health conditions are and why we are doing this particular problem, why we are doing this with particular, dealing with this particular problem. So right now, 1 in 8 people live with a mental health condition. 71%, 71% of the people who are diagnosed with the mental health conditions do not receive any kind of support. And at the same time, only 2% of the budget, 2% of the annual budget goes into this particular space of mental health, which is again quite absurd. If we talk about where exactly things got bad, then COVID-19 is a very recent example. During COVID-19, the number of patients got increased significantly, but at the same time, the number of support providers remained same. And this caused a huge gap between the number of support providers and the number of support seekers. New York Times specifically highlighted nobody has openings, mental health providers struggle to meet demand. See, the problem is not just on the seeker side, it's also on the provider side that they're unable to provide the right number of support that they wish for. If you want to see the number I'm talking about, that let us take an example at the bottom of my screen for pre-COVID era and the post-COVID era, that is 29 versus 2021, you see a clear 30% jump in the number of people who were reported to have anxiety disorder or depressive disorder, clearly marking that there is a need for some automation that can be done in here. And in our case, we are dealing with the automation of counseling summarization. Since we are dealing with the counseling summarization, you will see on the left side of the screen, there is a counseling dialogue over there, a conversation between the therapist and the patient. Our aim is to build a counseling summary, an effective counseling summary. But since a sensitivity is associated with this particular problem space, we cannot deal this particular problem with any dialogue summarization task or any conversational summarization task or any meeting summarization task. Here, an emphasis should be on the domain knowledge nuances and structural understanding of the dialogue. And that is why our work that deals with the dialogue conversation also introduces a novel planning engine right before the generation of the LLMs. We'll see in detail how we do it. So yeah, here is the problem statement where we pass our counseling dialogue, which is typically a conversation between a therapist and the patient, to a foundation language model. Now, this foundation language model in today's world can be anything. Let's say Llama 3, Llama 2, GPT, T5, the old age models also, or or like any state-of-the-art small language model or large language model. Now, before this large language model generates anything, yeah, I mean by using the large language model head, we introduce our planning engine. Our novel planning engine takes care of the domain knowledge encapsulation also. And the other thing that it takes care of is the structural knowledge encapsulation. The objective of introducing this layer is to force the large language model to hallucinate less and be more clear and structured in terms of the generation. All right. This we do by filtering and fusing the relevant information and guiding the generation process of the large language model. We'll see how. So this is our proposed method. We call it piece. This proposed method may look like a complex thing at the start, but it's a collection of two major modules, as we just discussed. The two major modules are domain knowledge module and the structural understanding module. If you want to see specifically the highlighted part only, right now on the screen, you would see only the domain knowledge infusion track. Let's walk through the pipeline of this particular module. At first, we give the whole dialogue with the speaker labels and the counseling components label, utterance by utterance to an utterance encoder. Now, this utterance encoder representations goes through a series of layers of RNN and then followed by attention block, then followed by dense layer for the counseling component classifier. This particular counseling component classifier is one of the three classes that we are doing here. It's typically a classifier only, which is responsible for a three-class classification. These three classes are reflecting, patient discovery, or talking about symptoms or reasoning. Now, this three classification is a method that has been proposed within the dataset paper. Once we get the representation, once we get the output of this particular module, what we get is a set of array that tells us whether a particular utterance is counseling relevant or not. We pass the final representations to the another module, to the next module, which is called knowledge filtering, which is a composition of where we technically employ the PHQ, the patient health questionnaire lexicons. We compute the similarity of each utterance with respect to all the patient health questionnaire, and we compute the aggregated similarity with and compare it with the threshold. If the similarity is above threshold, we count it towards domain knowledge enriched, and if not, we count it domain knowledge not enriched. Okay. The final set of utterances that we get over here goes to the knowledge scaffolding, which is again a part of the domain knowledge infusion track only. This knowledge scaffolding has been long studied. We fused the classical knowledge scaffolding method to adjust it to our setting. We divide the utterances. We create two kinds of representations within the knowledge scaffolding. The first one is the contextual utterance representation, where we employ BLEURT for utterance representation creation. And the second one is non-contextual utterance representation, as it is in the classical one using BLEURT. We concatenate the two representations and pass it through by a LSTM layer. And on top of that, we employ a self-attention module. The final representations out of this knowledge scaffolding is a representation of one whole dialogue that is domain knowledge enriched and relevant also, because at the first step, we fetched out the counseling relevance, and then the second step, we fetched out the domain knowledge relevance. Okay. Now before merging it into the final module, let's discuss the others major module also, which is structural understanding. Now let's start from the very step zero, where we pass our data to the structural understanding module. Within this structural understanding module, we employ sheaf learner, which is nothing but a sheaf convolutional network. The sheaf convolutional networks are made up of unicellular sheaf. This unicellular sheaf are interpreted to be encapsulating better structural information. Sheaves are long studied, starting back in 1980s and all, has recently caught attention when researchers have studied the encapsulation ability of the sheaf networks on top of graph. We convert our whole input into a graph structure, where you will see we construct our own graph. Each node is an utterance, and the edges between them are directed, showing the progression of the dialogue. In addition to that, you would also notice that there are two additional labels, T and C, signifying therapist and the client speaker labels, and each utterance is associated with these nodes as per their speaker labels, either T or C. Now, the representations out of this particular module is a representation that is structural aware, that is structure aware. The idea, the next idea is to merge these two representations that we get as an output from a structural module and the domain knowledge module. But the idea is a bit tricky because what we are planning to do is on top of the representations of the last layer of the foundation model. Okay, let's understand this clearly. On this screen, you would see here, the last hidden representations of the decoder typically is acting as the query over here. What we want to do is put an attention block right before the language model head. What is language model head responsible for? The language model head is responsible for the next token generation that we usually know in on top of any language modeling step. But before that, we put an attention over here. We call this rotating attention for what? Because our query remains same, the last hidden representations of the decoder, but the key and value are continuously alternating between the domain knowledge representations and the structural understanding module representations. For one step, so technically, this act as query for one step and value as another step. And when it is value, this act as query, this act as key, and when this is key, it acts as value. If you talk about the formula step, that this quick key and value are getting replaced for a single step, and the representations we get from both the alterations are being concatenated over here. This concatenated representation is passed through the language model hand, and then the next token generation happens. This is how the complete pipeline looks like. Although I do understand that the complete pipeline is can be explained in more clarity, but due to the time constraint, I would limit it to this much only. You can feel free to reach out at the poster or email me with doubts or clarifications. Let's look into the results and ablations. We compared our method with the 12 competitive baselines, and we observed a clear improvement in the performance with a notable 10.11% improvement in the ROUGE-2 score and 6% in the RL score, ROUGE-L score. We see a very competitive results in the BLEURT score on the last column with a very minor drop of 0.09%. But I would like to highlight that the previous state of the art over here was CONSUM back in 2022, reported back in 2022. And we are surpassing it on all the possible metrics with a clear margin of more than 15%. On the other hand, you will see the ablation study that we have performed. The ablation study is composed of only two major modules that we have proposed in the planning engine. And over here, you would see if we not include the structural knowledge, you would see our model's performance deteriorates. Also, at the same time, if we not include domain knowledge, again, the model's performance deteriorates. The findings underscore that the necessity of both the components is essential for the optimal results. Again, we also wanted to check out whether this particular planning engine, which is again designed in a way which is plug and play kind of thing. You can plug in with this. You can plug this in on top of any large language model or a small language model. Hence, we wanted to check out whether it is applicable to other large language models also or not. Okay, that is why we picked three different most competitive large language models from our baseline list and checked it on top of Mistral, Zephyr, as well as Llama. And we observed in general, the models tend to perform better when plugged in with the planning engine. In addition to that, it is clear that we are dealing with a sensitive space of mental health counseling summarization, and dealing with those standard metrics is not enough. That is why we added two other evaluation assessment, two other assessment criteria. The first one is the domain relevant metric. We evaluated the counseling summarization method, the generated summaries, the generated counseling summaries on MHIC metric, which stands for Mental Health Information Capture, specifically designed by the previous state-of-the-art paper for the evaluation of counseling summaries. This particular metric evaluates the generation on all the three major um, counseling components that they have proposed in their paper. We observed that we compared our model's performance on MHSE metric across three major spectrum. The first one is the CONSUM model, which is the previous state of the art. The second is the Mental Llama, which is the best performing baseline. And third is ours, the orange shade piece model, our proposed method. We see a clear improvement across all the counseling components and on all the factors. Also, at the same time, we perform a human evaluation to assess whether the model's general summary is readable to human and is readable to human evaluators or not, or in general to human or not. We observe that for the four metrics that we have chosen, relevance, consistency, fluency, and coherence, out of these four, on three of these four metrics, our model performs well. Although however, on the fluency metric, the model's performance is quite competitive to the one we have in the list, that is Llama and Mental Llama. Evaluators added a comment over here that large language models are good in one thing, and that is generating coherent and fluent text. And that is why evaluators found fluency to be better in Llama and Mental Llama than Peace, but the results, again, as I highlight, are very competitive in nature, with just a 0.04 of difference in the maximum and minimum thing. With this, I would like to bid thank you. You can scan the QR code on the left side of the screen for paper code. This typically takes you to my website where you can find everything. I would like to thank all my co-authors and listeners over here to reach this far. Thank you.